Alright, what's up guys? My name is Matt, and this is the first video on my math tutorials channel. Every week I'll upload a video of me doing a problem, whether it's a contest problem like today's, or a problem from a textbook or whatever. Today I'm doing problem 13 from the 2012 AMC 12B. So, two parabolas have equations y equals x squared plus ax plus b, and y equals x squared plus cx plus d, where a, b, c, and d are integers, each chosen independently by rolling a fair six-sided die. What is the probability that the parabolas will have at least one point in common? So a good strategy in general for problems like this is to imagine what the problem is saying. And so if you ignore all this stuff with the variables, it's really asking about two parabolas and whether they'll intersect or not, right? Because having one point in common means they intersect. So immediately think, okay, well, they could intersect obviously something like that, right? Or they could, be the exact same, or they could actually not intersect at all, right? If they did something like this. Um, Ignore the bad drawings, by the way. And so seeing that there's a possibility that they don't intersect at all, we can immediately eliminate option E, right? Because a probability of 1 implies that it's 100%, and obviously there's a possibility that they would not. Um, so now another thing that's useful, we know that they are going to intersect each other, right? We're trying to find the probability of that, which means that the equation will have the same value, so we can actually set these two equations equal to each other, right? So we can say x squared plus ax plus b, right, is equal to x squared plus cx plus d. Okay, and so from here, you want to just reduce as much as possible. So it's pretty clear that you can subtract an x squared on both sides, right? And that'll actually help a lot. So now we have ax plus b equals cx plus d. And so now we have things on both sides. It's kind of confusing. We want to eventually combine like terms in a way, right? And so for that we really want everything to be on the same side. If we have just 0 by itself on the right side, then we can definitely handle that a lot easier than this. So I'm going to move everything to the left side. So ax minus cx, right? Keep that stuff together, plus b minus d equals 0. All right, so now it's important to realize what's really going on in this problem. The x is going to change, right? Because that's like a line. That's how it works, right? The x increases. But the a, c, b, and d, those are all going to be determined before you even draw the parabola. So really, these aren't actually changing. These are kind of just constants. So you can just treat them like regular numbers. So you can actually factor out this x right here, right? X parentheses a minus c plus b minus d equals 0. So like I said, since these are just regular numbers, you can really just think of this as x times a number plus a number, right? Because you can think that as one number, think that as one number. Um, and that should look familiar. That looks very similar to the equation y equals mx plus b, right? X times a number plus another number. So really this right here is the same as saying a linear line, right? Because this is the equation for a linear line equals 0. And so you start, be a good idea at this point, right? Just draw coordinate planes, try to think about linear lines, right? And for the most part, it seems like they're almost guaranteed to hit 0 somewhere, right? But there's actually one situation where they wouldn't, and that's if it's a straight horizontal line, right? Because if it's parallel to the x-axis, right, it will never actually touch it. And so this happens when the slope is 0. So m equals 0, right? But m, in this case, that number that's being multiplied by x is actually a minus c. So for this to be the case, we would need a minus c to equal 0. So obviously, if you rearrange, add c to both sides, you get that a has to equal 0 for it to not work out, so that they intersect each other, the parabolas. And so if you want to find the probability of this, right, a can be whatever we want, right? If we're rolling a before we roll c on the die. So really, there's 6 options for a. But then whatever we get for a, we have to match that with c. So then there's only one option for c, for a total probability that a equals c of being 1/6, right? So you might say, oh, well, we start with 6/6 chance minus 1/6. So we're left with 5/6 that they intersect. But actually, there's a situation where a equals c and they still intersect because this still ends up equaling 0. And that's if it's right on the x-axis. And so obviously that will only happen if slope equals 0, right? Same as before. But also the y-intercept right here equals 0. So b also has to equal 0 in this scenario. And so since b minus d is our b from this equation, we would say if b minus d equals 0 and this, and a equals c, then it actually will, this will equal 0 and our parabolas will intersect. So same thing here, b equals d. And so again, the probability of this happening, same as before, b could be anything, but then d has to match it. So the total probability of this happening is 1/6, just like this. So really we have 1/6 of the time, right, it won't work out, right? So 5/6 of the time so far, the parabolas will intersect, right? And then another 1/6 of the time, they will not intersect because A will end up equaling C. But really, 5/6 of the time that A equals C, that's true. But 1/6 of the time, right, when B also equals D, which will happen 1/6 of the time, then 1/6 of the time that B equals D, then 1/6 of the time A equals C. In that scenario, this will equal 0 because it'll be on the x-axis, which means the parabolas will intersect. So this also is allowed. So now we want in this problem the probability that they have at least one point in common, not the probability that they don't. So we want to take that 5/6 and add it to this 1/6 times 1/6. So now we have 5/6 plus 1/6 times 1/6, which is 5/6 plus 1/36. And if you convert that to 36, you end up getting 30/36 plus 1/36, which obviously equals 31/36. And so our answer looks like it is D. So now, some important things from this problem. For one, representing this geometry, right, this stuff right here, with algebra. Usually, you're going to have to end up doing that at some point because geometry can be useful for visualizing a problem, seeing what's going on, but at some point you're going to have to use numbers and convert to some sort of algebra, especially in a problem like this where they give you so many variables, right? It's probably going to work out this way. So that's something to keep in mind. Also noticing these patterns, right? Noticing that this is actually just a linear line. And along with that goes realizing that this A, B, C, and D, they're variables technically, but really you decide them before the problem even starts in a way. So really you can treat them as regular numbers and then that fits this pattern of being a linear line. So hopefully that wasn't too confusing. I know probability is not my strong suit, so I wouldn't be surprised if some of this stuff around here got kind of complicated. But really it's just, A doesn't equal C. This is when A equals C and B doesn't equal D. And this is when A equals C and B also equals D. Right, so this goes with that, this goes with that, and this goes with that. And so you want to add this one right here and this one because those fit this equation. So that's it for my first video. Let me know what I can do better next time. I'm sure there's a lot of things, probably handwriting for one. But yeah, thanks for watching.